This video, we're going to look at how to identify and handle errors in datasets. I like to think of errors as data that should not be there, but there it is. Okay. First, let's think a little bit about what the possible sources of errors are. That is, what causes errors to be in the datasets in the first place. So some various sources of errors might be typographical errors, meaning that someone just typed a C instead of a V and so on, letters next to each other, or typed a 7 instead of a 6. Then there are different data coding standards, meaning that, and this mainly comes into play when there are different data sets that are brought together, but that might have different ways of coding the same thing. And so, for instance, maybe a North American data set uh, takes some data from Canada and then combines it with some from the United States. Now, international country codes, Canada is often coded as CA, and in the United States, the state of California is also coded as CA. So, bring those two data sets together might end up making it look as if Canada is one of the states in the United States, which ironically some Americans get confused and think sometimes. But that's one example. Another issue are different source languages, computer systems, or number formats. So, in some number formats, especially in Europe, the decimal point for numbers is a comma, whereas in English systems, the decimal point is usually a period. And so maybe if data is imported from one system that uses commas as decimal points, it might be interpreted as thousand separators, and the numbers with decimal points will be multiplied by thousands, and that introduces massive corruption of the data. There's also the possibility of deliberate corruption of data, which is where people deliberately, intentionally change the true values. So perhaps if you're collecting a survey, people might understate their age, they might reduce the value of their ages, or they might overstate their income, so those values are inaccurate. Or sometimes even internal employees, perhaps a sales manager, might inflate the number of sales they made in a certain period to make their performance look better. So these are various sources of errors from different causes. Now take a look at this small data set and pause the video for a moment and see if you can identify any errors here. There are at least two errors to find. So we have some different kinds of errors. There are numeric errors. You might have identified an age of 333 being rather unusual. And numeric errors are more obvious if they're unusually high or low because they stand out. However, there are, when a number seems reasonable, it might be harder to detect. So, for instance, suppose that this number here, this age for this person, is actually at 35. But when it was being typed in, the numbers were accidentally inverted and appeared to be 53. Now, when this kind of error occurs, unfortunately, it's almost impossible to detect, especially if you have a large data set of hundreds or thousands of lines, because it looks perfectly normal and it's perfectly legitimate. Um, that's the negative side. It's very hard to detect such normal looking errors. On the positive side, it really doesn't matter because numeric analysis are usually done on averages. And when a number which is within normal range is average with hundreds or thousands of other numbers, the average changes in a very minuscule way that does not meaningfully change the analysis. It's the large numbers that stand out, either very much higher or much lower. The ones that stand out are the ones that can risk altering the analysis, but they're easier to detect because they stand out. The other error in this data set is a text error, where for gender, which should be male or female, well, L, what exactly does that mean? If you have only a few categories, then it's relatively easy to detect those that stand out as errors. Yet this is also problematic in the sense of what is the true value. And so next we'll look at, once you've identified errors, well, how do you correct them? So determining how to correct them depends largely on the factor of whether you can identify what the true value is or not. So first, considering if you can identify the correct value. So to identify the correct value, you have to go back to the original source of the data to understand what it really is. You can ask the data providers, so where they got their data from and each line of data. Sometimes you can consult with subject experts to see what are reasonable ranges. You can discuss with your colleagues that you're working with on the team. And through these different means, sometimes you might be able to successfully detect the original source. So if you can find the original value, then just fix the data. You replace the correct value with the correct one. So here, perhaps someone typed 3 too many times, but when you looked up that person, the true value of their age is 33. However, if the correct values cannot be identified, and this might often be the case where if you have a very large data set, you cannot reasonably check up every error. Sometimes the data might be anonymized, you don't know who that person actually was. Then, in that case, if you cannot identify the true value, then you need to delete that erroneous value. You know it's an error, so it's better to have a missing value, which is also a problem, but a missing value whose true value you don't know is better than a value that you know is erroneous. Then once you now have a missing value introduced into your data set, then you can handle it through the various options for mixing missing data. So there's another video on identifying and handling missing data. So based on the nature of the missingness there's various options: listwise deletion, deleting the entire row of data; variable deletion, deleting an entire column of data; pairwise deletion, where the statistical software handles it; or imputing the values, trying to guess the most probable value. And so these are the different ways that you might deal with errors in your data set.